Hello. So I modeled a very basic entrance hall of an apartment building, and I will show how to apply waffle structure as an interior design element. So basically, I go to Grasshopper by writing Grasshopper into the command line in Mac. You can also click this button and then it opens Grasshopper. I would like to get references from this entrance building in order to create my geometry, because I'm applying it to this specific space. So for that, we need to take some reference points or reference geometry into the Grasshopper. I will close these solid walls and solid geometry, and then I will have a sort of a light drawing of on my entrance hall. So first of all, I would like to create waffle ribs covering the walls. In order to do that, I need to reference some points of the walls. So creating points, Grasshopper, you can basically double click and then search through what you're looking for, and then the Grasshopper will give you a list of things that that relates to that keyword, so you can select as well. And then probably you're familiar with these steps from the previous tutorials, so I won't be repeating it. So basically, I created empty components for points. And then I want to reference this wall. For that, I want to use so I want to be in the same layer, so I basically create points. Yeah. I'm referencing. I reference the points. And then we give references from the left wall. So it's this. Set 1 point again. It's yeah. So you can group your set of points. These are the references that we get from the entrance hall. So by selecting the components you would like to group together, and then right click, group, doing the same for these ones as well, group. And now you can even give names for that. For instance, by giving the keyword scribble, then you can create text in the canvas. So let's say it's the right wall points, and let's make it a little bit smaller, and then select this text, right click on the group and then add to the group. I do the same for the right wall points, left, sorry. I can basically copy paste this and change. So this is sort of a documentation that you can do in your codes. Okay, you can even change the font design and its font size as well, but it's okay for us. So if you click here, you can actually change them. So it's always good to document your code, because you will forget in a couple of weeks or in a couple of days what you create, because it's going to be a huge mess afterwards. So if you just keep these components of generic, like points, just as PT, and then without any definition, you won't be able to grasp what you've written, even if you wrote it. So it's always good for you to keep track on your traces and what these components mean. Especially in much bigger scripts. So now that we also documented a little bit of our references from the site, we can start. Now what we would like to do, we would like to create waffle ribs that are covering these walls. First of all, we need to create a surface, and I'm writing plain surface. So this component actually calculates a surface based on a given plane and the size on the directions of that plane. Now it's written, if I go a little bit closer, now it's written as X and Y, because the default plane is XY. So the size is here, the given sizes are related to that parameters. But if you change the plane directions, or if you change it to, for instance, instead of X and Y, you change it to Y and Z, which that our walls are located. So our walls are located on the Y and Z plane over here. So for that, double click again on the canvas. So find the component YZ plane, and then as you can see that the plane, it's defined on the origin, because the default point for that plane to start or to base on is the origin, and it's on Y and Z directions. And since we are not using X and Y, but we're using Y and Z, we can reset these names as Y by right-clicking on the node, and then it will give us this menu, and then just clicking here and then writing that. Okay, so we can define the base point. Currently it's on the origin, but we would like to create a surface that is here on this side. So then I will just give this point as the reference to that plane. So now our plane is moved over here. Yeah. And now we need to give a size on the Y and Z direction. You can basically give any number by number slider, I think the number slider, or just double clicking and writing a number. In this case, I write 1000. That means actually 10 meters. First of all, you can just go back in Rhino and then writing distance in the command line. You can measure a distance between 2 points. In this case, it's 670 centimeters. So basically here double clicking, rewrite the same, and then give. And doing the same for the Z distance. And it's 300. I just copy paste this and then write here 300 and then plug this into here. Yeah, so we have a plane with the right dimensions but at the wrong place. Since that Rhino and Grasshopper uses the Cartesian space, that you need to always initialize your numbers or your measures with a certain direction that indicates where they are on the Cartesian space. So in this case, this point is the origin, and then therefore we need to define the distance accordingly. So it should be on the y axis, it should be minus 300 instead of 300. So then it's negative. I just plug this in, and then we see our plane is created as we want to on the correct position. So this is one way. The other way is we can directly measure the distance by using these points that we reference. So what this component does, it basically takes 2 points and then measures the distance between these 2 points. So we can reference this one and then this one for the Y size, and then we reference point 1, we input point 1 and then point 2 in order to measure the size of the Z. So this distance, and then it should be on the negative side. So then we define S. So, and it's the same surface. What we have done, we actually get references and then use these references as the parameters. So what it means, that if you change the position of this point, Grasshopper geometry reacts to that. So here we don't need this sliders anymore. And then we define the surface. We will do the same for the left wall. distance. And then we created the left wall here, over here. Okay, so now let's reference them one by one. First, the overall wall. Let's see this one, and then 1 point. This is the third one, and then this is going to be the fourth one. Okay, so surface. This time I will use surface 4-point surface. So this component takes one by one the points and then define the surface based on that. So which is a bit different than this one. Okay, so, and yes. And see that we also would like to subtract the elevator door surface in order to get the net wall surface in here. And for that, let's say again, let's define one by one again the elevator points. So we are mapping our geometric definition, our parametric definition into the site. Is the fourth one. And we will use the same component, surface 4 points, surface points, and plug each point. Now we get this, so that we have these. We go to intersect tab, and now we are in the last subgroup called shape. And then we have region difference. So let's first plug this in. So this is the region that we would like to see the difference from the second region. And then if I write boundary surface, and then it will create a surface inside of that boundary. So then let's plug this region, and we got it. So now what we want to do, we want to define the positions of the waffle ribs. So remember that the waffle structure has two types of ribs, orthogonal to each other, that on the vertical side and horizontal side. In order to define the positions of the ribs, we need to create curves on the surface. We will use a component called contour. So this component needs a base shape. In this case, it's our right wall plane. So you define a point that will create a plane. So then let's say we use this point, and then you give a direction that I want to, let's say first I would like to get the vertical ribs. So y along the y-axis with a distance of, so a number slider, coming a little bit closer, then we can directly write into the slider 20 or Yeah, we can check it out. So yeah, we've created curves on the surface on the direction of y and with a distance of 20. Could be 10, then it's more dense. It could be, and it's more apart. So let's make it 20. And now we created the vertical lines. We need to create as well the horizontal ones. Okay, similar logic and similar components. Let's move it, this group of components, a little bit down here. Let's input the same point, so it's already there, and this time it's we would like to create the curves on the z direction, so you can see here, and yes, so now we created where the ribs should be. We need to define the width of the ribs. For that we use move. We need to move these curves along the x-axis, so x unit, and we have a set of contours, and we need to define the ribs out of them. So for that we will use a component called ruled surface. So just drag and connect the first list of curves here, and then do the same. Yeah, let's see that we've created vertical surfaces. But we're not done yet, because these are only surfaces and then they don't have a thickness. We would like to create ribs with a thickness. For that we will use the component called extrude, that it extrudes a base geometry on a given direction. So the base geometry is, in this case, a set of surfaces that we plug into the base geometry, that the created surface over here. And now we need to define a direction vector. And you can know by heart, or you can get help from Rhino, which direction we should create the thickness. We should define the vector direction. So you can see that on the y-axis that we should define. Yeah. So unit y. So we will do the same for the horizontal ones here. Just copy and paste this part. We will change this one, and we will change that one as well. So here we have the horizontal curves, and now we would like to move this along the x-axis. So X. X. So we have the moved list of curves, and then the original curves, horizontal curves here, and plug this horizontal curves instead of the previous list. So now we created horizontal surfaces that are 20 centimeters apart from each other, and then we will extrude them in order to give a thickness to each of them. So the direction should be Z, unit Z, and now I will use the same thickness, 5, and yeah. Yes, so here we created a very generic waffle . We can actually change the angles of the waffle ribs, that now they are orthogonal to each other, but we can define an angle between these ribs. For that, we need to define the contour curves with an angle. I double click and then rotate. So rotate this component. This component rotates a vector around an axis. This is what we need. And then if you hover over, you will see a little explanation of the component. And if you right click, you can also select help here and then get more information about what are the input parameters and what this component will give us. So here you see that you give first a vector to rotate. In this case, we would like to rotate this y vector, and now we need to give an rotation axis. So in this case, we would like to rotate this vector around x. And we need to define a rotation angle and in radians to do that. So first of all, we just plug this y vector we defined here. It's a unit vector, and we would like to change it around x-axis. So then x unit. Because we are only giving a direction, we are not defining the length or magnitude of the vector. We don't need that. We're just giving the direction. And so therefore we can use unit vectors. But if you would like to give magnitude, we can also change this value here, as we did over here. So, and angle. So for that, we can just create a number slider, a specific slider, then right click, edit. It will give us this slider preferences, and then minimum value, it's 90 minus 90, and then I need to convert this degrees into radian. degrees. So what this component does, this takes a degree input and convert it into radian, angle in radians. So I just plug this into that radians component, and then define the degrees and then convert it into the radian. So instead of y, the unit y vector, I plug this into that component, and then I can start changing. So you see here over here that the contour curves are changing their values. Yeah. And we can do the same for the horizontal ones, or we can just leave it like this. Now we have ribs that are perpendicular to the wall because we defined the move with the vector of x. If we change it to xy, this vector will result in an inclined ribs. These planes that are all perpendicular to the wall. Let's make a little, give them a little inclination. We can also do that. Let's go and change a vector. So you can also construct vector by double clicking on the canvas and then searching vector. So vector x, y, z, that is a component that creates a vector. It has to be 20, not 1. So let's say it is negative 20, 20, and it's 20, and this should be minus 20, and then yeah, you see that we give a little inclination. As well. And the final, yeah, so you can use the similar, you can use the similar logic to give an inclination to the ribs on the horizontal axis as well. Yeah. So the second step will be how we can change the thicknesses of these ribs on specific locations. So then sort of morph or transform these ribs into something else, for instance, to a sitting element. For that, I will show how to morph a surface first. So this surface, and then create contour curves in order to define the ribs positions.